Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ASU-actuary. Here's problem number 3 from the last exam MLC from late April 2018, and since these topics are also on long-term actuarial models exam that starts in the fall this year, 2018, it's an exercise for exam LTAM for today, May 24th, 2018. A couple, both age 65, have the option to receive one of the following: a life annuity of F per year, payable at the beginning of each year while at least one is alive, a lump sum of $100,000 if both lives survive 5 years. You are given mortality follows the illustrative life table. Interest rate is 6%, and a very important observation here is that the interest rate assumed in the illustrative life table that you get on the test has that interest rate as the assumption in the calculation of all actuarial present values. So you can use the single benefit premium for life insurance or life annuity or endowments or anything from the table with this interest rate. The future lifetimes are independent, and the actuarial present value of the payments under the two options are equal. Calculate F. So this is the solution. A life annuity of F per year, payable at the beginning of each year while at least one is alive, has the actuarial present value of F times A double dot 65 colon 65 with a line above it which indicates that annuity is paid until the second death. On the other hand, a lump sum of 100,000 if both lives survive 5 years has the actuarial present value of 100,000 times the actuarial present value of a pure endowment, payable as long as the joint life status 65 colon 65 is alive after 5 years, so if both of them are alive 5 years from now. The interest rate is 6%, so we can use the values from the illustrative life table. And since these two actuarial present values are equal, if we set them equal, then F will be equal to 100,000 times 5e 65 colon 65 divided by A double dot 65 colon 65 with a bar above it, indicating an annuity paid until the second death. And now we use Pustek's that tell us that the annuity paid until the second death plus annuity paid until the first death is equal to the sum of the two individual life annuities. Again, I call it Pustek's because this is just like the story from Winnie the Pooh when he invented the game of Pustek's. The game worked this way, that you throw 2 sticks into the river on one side of the bridge upstream so that you can go to the other side and see which of the 2 sticks comes out first. Now you have to make sure that they're different. So he at first threw 2, I think, cones in the river, but they were the same size. He couldn't tell which one came out first because they were the same size. But then he threw in a long stick and the short stick. And then he ran to the other side, and the long one came out first, which is the way he wanted it. And then the short one came out second, which is also the way he wanted it. So he won twice. Right? Now, if you don't see that that's the same as A double dot 65 plus A double dot 65 equals A double dot 65 colon 65 plus A double dot 65 colon 65 with a bar above it, then I'm not sure if I explained it well, but I can't believe you don't see that. So it's, or let's say AX plus AY is equal to AX colon Y plus x colon y with a bar above xy, because if the short stick comes out first and the long one second, well, you have both sticks either way. So you don't really win twice, you win once, right? Okay, I probably shouldn't be explaining this any further, but that's why I call this formula POO-sticks. And you need to know POO-sticks for the test, because POO-sticks is essential. By the way, POO-sticks does not assume independence of the two lives, but we will use independence in the solution in just a moment. So we write out the pure endowment in the numerator as 1.06 to the negative 5 times the probability of survival of the joint life status for 5 years. And at the bottom we have 2a double dot 65 minus a double dot 65 colon 65. Now the important thing to note is that these two annuities, the values are given in the table. So we can look them up and plug it in eventually and everything will be nice. But the probability, well, it's not directly given. However, the lives are independent, so 5p 65 colon 65 is equal to 5p 65 times 5p 65 because they're independent. And if you multiply 5p 65 times 1.06 to the negative 5, then you get a pure endowment, 5e 65. If you multiply the other 5p 65 by 1.06 to the negative 5, you also get pure endowment, except you only have one 1.06 to the negative 5. However, if you multiply the second probability by, again, the same 1.06 to the negative 5, and then multiply things again by 1.06 to the fifth, then you have the same thing. So that's why we can just write this as 100,000 times 1.06 to the fifth times 5e65 times 5e65. So really 5e65 squared. And what do we have in the table for 5e65? We actually have 1,000 times 5e65. Okay, this 100,000 is 100 times 1,000. But if it were a million, then it would be 1,000 times 1,000, so we could take 1,000, each 1,000 and multiply it by 5e65, and we would have it twice, so we would just have a square of it. So, well, what do we need to multiply a million by to get 100,000? 0.1. So we just write it as 0.1 times 1.06 to the fifth times 1,000 5e65 squared, and at the bottom we have 2a double dot 65 minus a double dot 65 colon 65. All of these things are now in the illustrative life table. We plug them in, we do the calculation, and we end up with 4,827.12 approximately, which is answer B. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. And good luck in your studies and good luck on the test.